Okay, continuing on today with our Laplace Transform playlist. I just want to do a few more practice problems, kind of overkilling it, but that's kind of what I'm all about. So what I'm going to do is we're going to do some problems from the web page. I'll provide a link to this quiz in the description. What I'm going to do is, starting from the main page, we can just navigate into the differential equations page, come down here. Now, just wanted to mention in here, you also have the Laplace Transform cheat sheet that you can use, and that's going to be helpful. But for what we're going to do today, we're just going to use this quiz, Laplace 101. Okay, to get started, we'll do this really easy, quick example. We have here just the Laplace. We just want to find the Laplace transform of 3 times e to the st. And we have a formula for this. Let's just look at our formula, our generic formula for the Laplace transform of e to the at. This is going to be the same thing as 1 over s minus a. We derived this in a previous video. So for this, what I can do, I can actually factor the 3 out, because we've gone over that Laplace transform is a linear operator, so we can factor out a constant. So I can write this as Laplace transform of e to the 6t. And then we can use our formula down here. Now our a value in this case is going to be just 6. So for this one, we're just going to end up with 3 over s minus 6. We come over here and check it, and that's correct. Okay, here for the next one, we've got an interesting problem. We want to find the Laplace transform of minus 4 times t to the minus 1/2. And what I'll do first, I will factor, again, we'll factor the minus 4 up front. So let's just rewrite this as minus 4 Laplace transform of t to the minus 1/2. And we do have a formula for this. We did this in a previous video. This is going to be the case of the Laplace transform of just t to the n. What we found for this, now this is the non-integer case. Okay, so the way we expressed this in the previous video, we wrote this as gamma of n plus 1 over s to the n plus 1. So going back to our Laplace transform, our n value is going to be minus 1/2. So if we do this, we'll bring our minus 4 over, plugging minus 1/2 in here. This is going to give me gamma of 1/2 over s to the 1/2. But now the key for this is we want to get some value for the gamma function. What I like to do is actually just memorize a value for gamma of 1/2. And what we do for this is we write this as, we can remember this to be square root of pi. So for this one, our solution should be minus 4 square root of pi over s to the 1/2. We can write that as square root of s. Let's just see what we have over here. And that's going to match this one down here, the bottom one. And that's correct. Okay, this looks interesting. We have here the Laplace transform of 2t squared minus 1 times the Dirac delta function t minus 5. Okay, let's just recall our formula for the Dirac delta function. So what we found a few videos back was we've got the Laplace transform of f of t times the Dirac delta function of t minus, let's say, c. Then our formula for this is going to be e to the minus cs times f of c. So we just have to take our function here and evaluate it at this point c. Okay, that shouldn't be too bad. So looking at our problem, our c value is going to be just 5 here. So let's see if we can go right to an answer. The first part here is going to be e to the minus 5. I want to make the 5 clear so it doesn't look like an s. And then for this 2t squared minus 1, we just need to evaluate that at 5. So let's kind of write it out and make it clear. So this is going to be 2 times 5 squared minus 1. And let's see if I can multiply that all out really quick. So this is going to become 25 times 2 is 50 minus 1. So this is going to be just 49. You know, I really want to write it, I want to write it in the right order. So let's write it as 49 times e to the minus 5s. Come over here. That's correct. Okay, here's a good one. We want to find the Laplace transform of sine of 4t plus 4. And I did a video on, I grouped this together. I did one on sine and cosine in the same video for sine of at plus b. And so let's just look at our formula for sine. So if we have the Laplace transform of sine at plus b, the formula we found was, let's see, the denominator is easy to remember. It's going to be s squared plus a squared. That's just like if you just found regular sine. But where it gets weird is in the numerator. So let's see, the numerator is actually going to be see if I can remember. It's going to be S sine B plus A cos B. Well, the next thing in our problem here is we can see our A value is going to be 4, but our B value is also going to be 4. So let's just use this formula and see what we have. So this should be S times sine of 4. Now that's just going to be some numeric value, sine 4. And we'll have plus A value is 4 cosine of 4. And this is going to be all over S squared plus 4 squared, or 16. And let's check it. Looks like this one right here. And that's correct. So I think that's about enough Laplace transforms today. We'll keep going. We'll do some more Laplace transforms in the next video. Thanks everyone for watching. Have a good day.